Okay, I have a question about number 4 regarding how to properly graph. As you can see here, this is the average demand. Well, this is a demand curve. On this horizontal axis here, you have quantity, and on the vertical axis, you have price. And as you notice, it goes downward sloping because as the price goes up from 20 to 40, at 40 units, people would buy 30 of these bippity bops. But as the price goes from 40 to 60, at 60, when the price goes up, people buy 27. So 30 is greater than 27. So you can see that as the price goes up, the quantity demanded goes down. So much so that when the price of a bippity bop is 200 bucks, only 6 units are going to be bought, as opposed to when the price is $20, 33 units will be bought. So that's how you graph. And so this graph is asking you to figure out the total revenue. And the way to figure out total revenue is there's a formula for that. It's the price times quantity. So revenue has nothing to do with profit. Revenue is just how much money you bring in. So you take the price of what you're selling something for times the actual number of units sold. And then the problem asks you to graph it. So on this graph here, we have the price on the horizontal axis, and we have the total revenue here on the vertical. And so we just have to plug in our numbers. So for example, if I can grab this here, I stick this down here. Let's say I wanted to know what the total revenue is at a price of 20. I go here, and so I know that these points here are 33 times 20. I can take my calculator. I don't know if you can see this. 33 times 20. 33 times 20. So that tells me at a price of 20, my total revenue is going to be $660. So down here, at a price of 20, if I can grab this, I don't think it's going to let me grab it. All right, at a price of the 20, I kind of hover over here. It actually starts at 40. At a price of 40, there would be $1,200 in total revenue. And the way they got that was they took the price of 40. So at 40, how many units am I going to sell? You can go back up to here. At 40 units, excuse me, at a price of 40 units, we're going to sell 30. So 40 times 30 is the 1,200. So to plot that point, the price is 40. When the price is 40, total revenue is 1,200. And so this is just a total revenue curve. And total revenue curves are sort of like a derivative. And so they will curve, and there will be a maximum point here. So you can keep raising the price, and as you raise the price, depending on the elasticity, you will gain more money. At some point, though, the price will become prohibitive or become too high, and you'll start to lose money. So you want to price your good exactly at this top peak point here, right? And that point happens to correspond with 120. Problem goes on further to ask you in here, oh, here's the formula. So in here we have the price. For each price, we took price times quantity equal total revenue. This is just a graph of that. And then the problem asked you, according to the midpoint method, the price elasticity of demand between A and B on the initial graph is approximately, right? Price elasticity of demand. Again, it looks like a very difficult formula. Do not be flustered about it. Just sort of think about what it is. To get the percentage change, so it's basically a percentage change in quantity over the percentage change in price. So you do all of this math to get a number 13.33. Then you do all of this math to get a number of negative 0.22%. And then you're going to put those over each other. You're going to divide the 13.3, the percentage change in quantity, divided by the percentage change in price. Right? The midpoint formula, very simple. You're just going to take your point, and you're going to take Q2 minus Q1 over the midpoint between Q2 and Q1. And the way to find that is Q2 plus Q1 divided by 2, right? You drop all the pieces in here. So this right here on the numerator is basically the change in Q. Q2 minus Q1, also referred to as a change in Q, over the average of the two, which is Q2 plus Q1 divided by 2. Right? So the price elasticity of demand, when we have these numbers here, is going to be 13.33 divided by a negative 2.22. And we can kind of ignore the negative sign simply because price elasticity of demand, if we go back up to here, is always negative. because of the law of demand. As the price goes up, quantity demanded goes down. Makes sense. As the price of something goes up, people buy less and less of it. When we divide 13.33 by 22.22, we end up with a price elasticity of 0.6, right? Because that price elasticity of demand is less than 1, we would say that this is inelastic. Inelastic demand basically looks like a I, or closer to a vertical line as opposed to a horizontal line.